Hello and what's up everyone, welcome to the 7th or last video in our 7 days of computer vision project series where we will be covering simple computer vision projects using image processing and some open source tools. I am Viper from DataQuell and today we are going to write a code to make a gesture based calculator. Making a calculator is one of basic and fun projects in our early days of learning programming, and I was also one of them to make a calculator. But in this project, we will be making a calculator that can be run with finger in air. And we won't be using some kind of machine learning model to do fingers counting, but we will be using simple rules. Without getting any delay, let's get started. Most of the early parts of these projects are taken from the previous project, so I'm only going to explain them here instead of doing code along. But I encourage you to pause the video and follow along. First thing we will do is import mediapipe for detecting hand landmarks, and then opencv for image processing, then numpy for doing array operations, and then matplotlib to plot image, and then counter from collection to count the items in the list. Then I have defined a usual dummy show function which will take image and figure size, then plots image on the given figure size. I have checked that function by giving black image. Next function is the Euclidean, and it is used to get the 2D distance between 2 points and return it. Then I have checked it by passing some values. This function is used to make some kind of gesture rules based on the distance between two landmark positions. Next, we will need to have a video source as a live camera feed, so I am using my default webcam. Then a tuple, f size is frame size. Additionally, I am taking drawing and hand modules from mediapipe solution. Then using the hand module by passing number of hands as 2 and minimum detection confidence as 0.2. Then, if the camera is open, read the frame. And we will also wait for the key event in every 1 milliseconds. If the frame read was not successful, then we will skip this pass. We will flip the frame to make it look like selfie frame and use previously defined f size to resize the frame. Since mediapipe expects image to be in RGB format, we will convert it to RGB and pass it to the process of hand module. If the hand has been detected, we will loop through them and draw the landmarks on the frame. At last, show the frame. If escape key is hit, then we will break out of the loop and finally release the camera and destroy all windows. Let's run this code. As you saw earlier, hand landmarks were visible, and now we will define few operators that we will be working on in this calculator. Let's define a list of operators that we will be using, and they will be plus, minus, divide by, and then multiplication, and then clear as C and equals to. Let's take a length of operators as we need it while taking operators column. Next, define an array OPD or operator details as black image of 100 rows and columns as far as frame size, and it will be in unsigned integer of 8 bits. This array will hold all the operators on the top of frame. Now we need to have a columns between where our operators will be residing on, and it will be within 0 to maximum column, and we need to have 8 columns to cover 7 operators. Let's make it integer of 64 bits, and we will take 2 consecutive columns to make a boundary, and within them will lie the operator. Now to show operator within the columns, we will loop through the columns. First, make leftmost boundary by making 0 to 2 columns color different, and then make leftmost column and right column color different. Then we will put text in the details panel within this column range. We will give the font style, line scale, color and thickness. Let's show the OPD. Seems that I got an error and I should have not forgotten I in list comprehension. I got another error in put text, and it is just error by not passing value properly. That is, it will be lying on the middle of the columns and which is the row, so make it a little bit logical. Now it is fine. As you can see, we have a plus in the first and minus in the second and so on, but I changed the value. We can see the change. This change does not matter much, but for the simplicity, let's use previous style. After doing this, let's copy this code and paste it on main code just below f size. Now we will create 2 ROIs, and why do we need that? That is because we want our calculator to be usable from both sides, and we want the count to be happening only if fingers are within the ROIs. So let's define coordinates L1, T1, R1, B1 for the first ROIs, and values as 50, 200, 250 and 500. Similarly, L2, T2, R2, B2 is coordinates value for second ROI, and 500, 200, 800 and 500 respectively for the values. Now we will draw the rectangle after we resized frame. We will replace top 100 rows by our OPD or operators detail panel. Running this, I got an error, and seems that I forgot to rename coordinates of rectangles. Now as you can see, details panel was visible along with rectangle. Now we will draw a pointer in our index tip position. First, let's extract the index tip from our hand. We will convert normalized landmark position values to frame world. But first give width and height of frame. And we will draw a circle on index tip position. Give radius as 10 and color as red. Running it, I got an error and I misspelled frame. Running it again, I got another name error. Initially our index tip won't be visible because the hand won't be detected, so we need to predefine a value for index tip. So let's keep -1 and -1 for index tip. Running it once again. As you saw earlier, the cursor was visible on the details panel. Next we will do something like counting fingers. So we need to have some kind of rule to distinguish between a folded finger and unfolded finger, and we will make that rule later. We will make a variable buffer h0 where counts will be placed. So to count all the fingers, we will check the difference between tip and pip position of a finger. So we will extract all the tip and pip for all fingers. As you can see here, I have extracted tip and pip position for every fingers, and please pause a video to see them. First, I have defined a tip and pip for index finger, and then for middle finger, and then ring finger, and then for pinky finger, and then for thumb and wrist also. We have extracted the tips and pips, and now is the time for us to make some kind of rule to count fingers. Let's see on the hand landmarks image here. For example, look at the index tip at 8 and pip at 6. On normal handboard, tip will be above the pip and their difference of y value or rows will be negative. And while folding index finger, the difference could be near 0. So by using this simple rule, we will do counting. Let's write a rule for index finger. If index tip and pip is not known, then we will check if index tip is inside our details panel. And since our details panel is on the top 100 rows, we will check for below 100. Upon being true, which means our cursor is on the details panel of operator, so we will check the column of index tip inside which column pair will lie in. So if found, we will get the index of the column pair and we will get the operator related to that column pair. And for counting fingers, we will also check if difference of row position of tip and pip is above fixed variable fp. But first, define fv as 10. If the condition is true, we will increase the buffer by 1. The condition is pretty simple and we will do similar for middle finger. If middle finger tip and pip is not known, we will check the difference between tip 1 and pip 1 and then increase the buffer. And similarly for other fingers also. But for thumb finger, we will check if it is far from the index pip or not. Now let's visualize our buffer by putting it in frame as a string. Now running it. As you can see in the screen, something is not right because it is showing 4 instead of 5. So let's see what can be the problem. The problem is while checking the index finger, so let's pull the code in a little bit left. Now running it once more. Now it is working fine. Let me try different gestures. Let's try to move thumb near the index pip and other gestures also. If I fold any fingers, it is not counted. If I show both hands, it will also show 10 and so on. So by using this simple rule, we don't have to do complex tasks, and most importantly, we don't have to use any kind of machine learning models just to count the finger. For simplicity, visualize our buffer in the middle of frame, and as you saw, it is working fine. Since we have written finger counting mechanism, now we will do some interesting things to do actual calculation. Let's define some more variables. Define our list values where we will store all the predictions. Then define prediction as 0, index fingertips as itips, current operator as op, output as none, equation as eqtn in string, and just like previous times, define show every as 15 and check count as 0. Now we will check if our wrist position is below the half of the ROI rectangle, because while we will be moving our hand to details panel, then we don't want that hand's fingers to be counted. So let's do it. If wrist is not known, then check if wrist is within the bottom half of first ROI, then we will do nothing. And if wrist is within the bottom half of second ROI, then again we will do nothing. But if both condition fails, we will make buffer to 0. So let's run this once again. If I move my hand above top half of ROI, the fingers are not counted. But if I moved my another hand, then it is also neglected. So there is some kind of logical error happening. What I need to have is ignore the finger counts of that hand which is above the top half. To overcome that problem, let's define a variable fcounts is empty dictionary where key will be the AND index and value will be the counts of finger. Then enumerate through the AND landmarks and define a new variable bv is 0. It will count the fingers in current AND. Then we will replace buffer by bv in counting parts. At last, just after counting all fingers, we will put finger counts into the fcounts dictionary. If the list is above the half of ROIs, then cancel out the fcounts value for current AND. Additionally, we will make a buffer as the sum of values of fcount dictionary. Let's run this once again. As you can see, it is working fine. If I take my both hands and one above half and another on normal place, it is working fine. Now we need to write something to make our cursor only move if index tip and thumb tip are near, and at that time we won't be counting any counts. First, make our flag move as false and we will check if thumb tip is near index tip or not. Let's check Euclidean distance if it is below 60. If it is, then we will make move true. Upon being move as true, we will cancel out the buffer and make it as 0. Else we will append buffer to values, but the calculation of buffer should be above checking the condition. Let's run this code. As you can see, it is showing 5, and as I move my thumb near to the index pip, counts will be 0. And even though my both hands are on ROIs, a single move mode will cancel out the entire buffer. Now we will do the important part, which is doing calculations. So let's check if show if is smaller than the check count, and if it is, then first make check count as 0. Then we will check for length of values. If it is above 0 and if buffer is not 0, then we want to find most occurred item inside the values. So make a dummy variable d and store dictionary of the counters of values in it. Then to find the most occurred value, we will first sort the dictionary and we'll reverse it. Then take the first item of the first tuple, which will be the most repeated item inside values list. We'll add that value as the string into our equation, and if prediction is not 0, then we will show the prediction on frame. Once done, we will also check for operators. If OP is not none and OP is not clear, then we will add operator on equation. But first check if equation is not empty. And if it is not empty, then we will check if current operator is not last item of equation, just to make sure same operator won't be repeated one after another. Then we will check if operator is equals to or not. If it is, then we will solve the equation and put it in output. We will use built-in function eval or evaluate to evaluate it. Then to make our calculator just like a standard calculator, take this output and erase equation, then put it in equation. Then we will print the result too, but let's print output along with equation. So move print part above. If the operator is not equals to, then we will simply add the operator on the last of equation. We will also need to make operator none at last. Then if our operator is C, then we will make output none, because C is simply clear, and we will clear out the equation and values too. At last, we will make operator none in every check count. Also make buffer 0, prediction as 0, and then empty the values list. At last, we will view output, and if output is not none, then we will put output in the frame. Similarly, we will put equation on frame 2. While finding the prediction, if the output is not none, we will ignore the output and the previous equation. Let me show a real calculator and explain it. If I do 8 plus 8, then result or output will be 16, and if I hit any number, then the 16 will be gone, and I want similar to happen in our calculator also. And if I do 8 into 8, it will show me 64, and if I hit any operator, then the 64 will be treated as operand, and now I am hitting plus, then 2, so the result is 66, and we are going to simulate this behavior. But what we also need to do is, after checking the equation, our equation might not always be solvable, so in that case our program could face error. So to prevent it, let's wrap evaluation part inside try except block. Upon error, print the error also. Again, if output is not none and operator is also not none, then we will add operator after the current output. So previous equation will be replaced by current output. Let's run this code. It shows me some error. It should be EQTN. And another thing we forgot to do is increase the check count in every frame. Now running it, As you can see, I am moving my hand in the RY and it is showing 5 in the equation, and if I go to clear, it will clear it out. And if I do 5 multiplied by 5 multiplied by 1 and go to equal to, then it will show me 25. And if I want to simply use number, then the 25 will be forgotten. Let's do something like 33 and then multiplied by 11 and equals to, and let me divide it by 3 and see the result. And as you can see, the print is also working. Sometimes we can get error with this code while evaluating, and that error is hitting operator after operator. Let's see it once. If I do 5 then multiplied by and equals to, then it will show me error, and the error can be two operators coming consecutively, and here 25 minus divided by 55, which is not a valid equation, thus I am getting an error. In this case, we need to do something like, if the last item of equation is an operator, then we will replace that operator by current operator. So just below checking if operator is not equal to last item of equation, we will clear the last item from equation, and then adding new operator will happen later on. Let's run it, and there is an error, and error is that I am using is. So running it, so I am doing 5 then multiplied by then divide, then sign is being replaced, and it is working fine. I think this is the end of this project. So thank you everyone for coming up to the last of this video, and I would be grateful to get feedbacks from you guys. If you found any error, problem or solutions, then don't forget to ping them on our comment section. The link to codes and blogs are in the description section. Please stay tuned because we have very interesting and helpful topics coming on the further days. My colleague Sagar is working on making contents to become a data engineer, and I will be working on making fun projects. But first project in my mind is making a project that will send me text message about incoming weather for entire day, because it is extremely helpful for people who live around my village. Stay safe, and I will see you in the next video.